In this video, we're going to discuss molar volume, and this is molar volume for a gas substance. So you've actually seen a word similar to this before, molar mass, right? And remember what molar mass means. It's how many grams of a substance is equal to 1 mole of a substance. So similar to that, this is basically the same thing, except we're talking about volume. So remember the unit for volume. Volume is liters. So we're talking about how many liters is equal to 1 mole of a gas substance. So let's jump into this. Here are your learning targets. And what I want you to do first is use the ideal gas law to solve for the volume of 1 mole of a gas at STP. STP it stands for standard temperature and standard pressure. So remember from our previous video, standard temperature is 273 Kelvin. Standard pressure is 1 atmosphere. Okay, so these are the values that you want to use for temperature and pressure for this particular problem. So let's go ahead and set it up. We're going to use the ideal gas law, PV equals nRT. So let's define our variables. We have N is equal to 1 mole, temperature is 273 Kelvin, pressure is 1 atmosphere, and remember we're looking at the pressure unit to figure out our universal gas constant, R. So since pressure is ATM, we're going to use 0.0821 and we're solving for a volume. So let's go ahead and plug it in into PV equals nRT and we're solving for a volume. Okay, our like units will cancel out and we're going to be left with liters. So volume is equal to 22.4 liters. So what does this mean? At standard temperature pressure, and because we're going to see this again, at STP, 1 mole of a gas, 1 mole of any gas at STP is equal to 22.4 liters. Okay, so that is the volume of any gas, 1 mole of gas at STP. Okay? Now that we saw for the volume of 1 mole of a gas, let's go ahead and calculate the density of a gas at STP, standard temperature and pressure. Our first example says an ideal gas has a density of 3 grams per liter at STP. What is the molar mass of this gas? Well, we're talking about density, right? And you guys remember the formula for density? Density equals mass over volume. But instead of using density equals mass over volume, let's use density equals molar mass divided by the molar volume. Okay? It's pretty much the same thing, right? And we found out what the molar volume is. The volume of 1 mole of a gas is 22.4 liters, right? And so let's plug it in. Given our density, 3 grams per liter, we already know our molar volume. It's something that we're going to just know by heart now, 22.4 liters per mole. We can determine that the molar mass is 67.2 grams per mole. It's as simple as that. Mass divided by volume. Again, but this time we're saying molar mass divided by molar volume. Okay? So go ahead and try example 2 on your own. Go ahead and pause the video and unpause when you're ready. So in example 2, we're talking about carbon dioxide, and carbon dioxide, you remember, is CO2, right? And so here we have the molar mass of CO2. Using your periodic table, you can figure that out. We have the molar volume, again, that's 22.4 liters per mole, right? So let's go ahead and plug in the values. So for molar mass of carbon dioxide, we have 44.01 grams per mole. Molar volume is 22.4 liters per mole. Divide those two numbers and you get a density of 1.96 grams per liter. That's it. Okay? Now, going back to this mole concept. Now, you might remember this picture from before, except now we have 3 arrows pointing to the mole, right? 1 mole, we previously learned, is equal to Avogadro's number, which is 6.02 times 10 to 23 particles. Remember the word particles? There are other words associated with this, like molecules and formula units and atoms and ions. All of those words tell us that we need to use Avogadro's number, okay? The other thing that 1 mole is equal to is the grams. Grams on the periodic table, right? So this, we know it as molar mass, okay? So remember, this one doesn't have a number because the mass of a substance is going to be different depending on what substance we're looking at, right? So we just need our periodic table for that. And what we're learning today is that 1 mole is equal to 22.4 liters, and this is what we call molar volume. And again, it's at the conditions of STP, standard temperature, 273 Kelvin, and standard pressure, 1 atmosphere. Okay, so this is for any gas substance. Okay, 1 mole of any gas substance is equal to 22.4 liters. So let's take a look at our first example. What is the volume of 1.3 moles of hydrogen? I'm going to start with 1.3 moles. And here we're going to set it up with the fence. And this is a simple conversion. The next couple of problems that you guys have on your paper, it's just a simple conversion of moles to volume or grams to volume and things like that. This is not stoichiometry because there is no reaction associated with these problems. Okay? So here we're going to practice setting up the fence. We're going to copy down our unit, moles. On top, we're going to write liters because it's asking for volume. And here we have liters over mole. That should look familiar, right? We just went over this, liters over mole. This right here is molar volume. So remember what molar volume is. 1 mole is equal to 22.4 liters. Okay, so we're going to put in those numbers. Remember, say it out loud, right? 1 mole. So where you see the word mole, you're going to write 1. Where you see the liters is 22.4. Okay, so multiply across. We're just dividing by 1 here. So like units cancel, and we get an answer of 29 liters of hydrogen. Okay, you try number 4. Go ahead and set it up. It is very similar to our previous problem. Okay, you're going to start with 33.6 liters. Bring that down. We're trying to find moles of fluorine. And when you're ready, go ahead and unpause to find the answer. And you should have gotten 1.50 moles of fluorine gas. Let's take a look at our next problem. Determine the volume of 22 grams of carbon dioxide gas. Well, this one, it involves more steps. Why? Because we are giving grams and they want liters. But we have to go through what? We got to go through moles, right? You can't go directly from grams to volume. So grams, we're going to copy that down. On top, we have moles of carbon dioxide. Again, we're going to copy that down, moles of carbon dioxide. And lastly, we have liters of carbon dioxide. So in our middle fence here, we have moles over grams, and that, again, should look familiar, and that's our molar mass, right? So molar mass of carbon dioxide is 44.01 grams. It is equal to 1 mole of carbon dioxide. And 1 mole of carbon dioxide for molar volume is equal to 22.4 liters of carbon dioxide, right? So go ahead and cross out the like units. We're going to multiply and divide. And then we get an answer of 11 liters of carbon dioxide. Next one. The next one is, you see the word molecules, right? How many molecules are in 33.6 liters of methane? So again, we're going to start with 33.6 liters. And remember what molecules is, right? Molecule is a similar word as particles. So somewhere in this setup, we are going to use what? We're going to use Avogadro's number, right? So let's first set up our fence. Liters of methane, we're going to go ahead and bring that down. Liters is going to equal moles. That's the only thing that it can equal, right? And we're going to copy down moles, and on top we're going to write molecules, okay? So again, just to reiterate, liters cannot equal molecules. Liters only equals moles, grams equals moles, okay? Molecules equals moles. And that's the reason why on the other side of the fence, that's what we're writing, okay? So middle fence, we have our molar volume. So 1 mole is equal to 22.4 liters. In our last fence, 1 mole is equal to 6.02 times 10 to 23 molecules. Cross out your like units, multiply and divide, and you get an answer of 9.03 times 10 to 23 molecules of methane. So go ahead and try examples 7 and 8 on your own. Pause the video. I don't show you the setup here. I'm just going to show you the answer. So when you're ready, unpause. And the answer to number 7 is 8.0 grams of oxygen. The answer to number 8 is 44.8 liters of nitrogen. Okay? Now let's take a look at stoichiometry. So now we're going to take a look at problems with a reaction, a balanced reaction. All right? So I'm bringing this picture back, right? We saw this with our stoichiometry lesson. And here the only thing that I added to this picture is this part here. It says liters of A and liters of B. Why liters? Because this entire video is about molar volume, right? So we're talking about volume, so that's why I'm now throwing in the liters. But look at the position of where I put liters. It's all the way at the end, okay? So remember, you're starting, these are your starting points, okay, depending on what the problem gives you, and these are your end points depending on what the problem is asking for, okay? So let's jump into our first problem. If 6 liters of hydrogen gas are used, how many liters of nitrogen gas will be needed for the reaction at STP? So again, that word STP, it just means standard temperature pressure, which really means that you're just going to use 22.4 liters per mole somewhere in your setup. All right, so we're going to go through the same steps. We're going to write down what we're given and what we're trying to find, and we're going to cross out anything that it's not really talking about. So we're given 6 liters of hydrogen. It wants to know liters of nitrogen, and we can cross out ammonia because it's not talking about it at all in the problem, okay? So we're going to bring up that picture, all right? So where am I going to start and where am I going to end? I'm going to start right here, and I'm going to end right here, okay? So everything else above it I can ignore because it has absolutely nothing to do with this problem, okay? So we're going to ignore this part here, all right? So let's set it up. We're going to start with our given 6 liters of hydrogen, arrow, moles of hydrogen, arrow, moles of nitrogen, arrow, liters of nitrogen, because that's what they're asking for, right? We're going to replace the arrows with the fence. We're going to go ahead and copy down our units, okay, from the previous fence. And we can see in the second fence here, moles over liters, that is our molar volume, right? So molar volume, again, is 22.4 liters over 1 mole. So where you want to, where you see the unit, that's where you want to write the number, okay? So 1 mole, 22.4 liters. Our next fence, moles over moles, you remember what that's called? Moles over moles is called the molar ratio. Remember that? So where do we find the molar ratio? You find it in your balanced reaction, right? So we're looking at nitrogen and hydrogen. Here's nitrogen. There's no number there, which means that it's 1 mole of nitrogen. And hydrogen, we have 3 moles of hydrogen. So what's the molar ratio? It is 1 to 3. Okay, so that's where we're going to put in our numbers. And then again, the last fence, liters over mole, that tells us molar volume. So we're going to use 22.4. Okay, good. And then we're going to cross out our like units, multiply and divide, and get an answer of 2 liters of nitrogen. Okay. Example number 10. Again, write down what you're given and what you're trying to find. Okay. So we are given 2 grams of water. We are trying to find liters of oxygen. We could care less about hydrogen, so we're going to go ahead and ignore that part there. We're going to cross it out. Let's bring up this picture, and where do we begin this time? Well, we're still going to begin over here with grams of A, so this time I can ignore that and ignore that. And we're going to end up here at liters of B. So ignore that and ignore that, right? So let's set it up. So your setup should look something like this, the top part, okay? We're going to go ahead and copy down our previous unit to the bottom. Moles over G, what is that? That is molar mass, right? So molar mass of water is 18.02 grams per 1 mole. So again, I found that using the periodic table, right? Hydrogen plus oxygen, okay? And then our next fence is the molar ratio. So again, we're looking at the coefficients, and we have a ratio of 1 to 2. And liters over a mole, again, that's the molar volume, right? So we're going to use 22.4 liters per 1 mole, okay? Like units cross out, multiply and divide, and we get an answer of 1.24 liters of oxygen. Let's take a look at our last example, and our last example is a limiting reactant problem. Just to practice it, okay, and go over it again. So here we're given 10 moles of hydrogen and 13 moles of oxygen. It wants to know how many liters of water it can produce. Which reactant would be the limiting reactant? Okay, so remember, this is the type of problem where you got to set up twice, right? So I'm going to start off one with 10 moles of hydrogen, trying to find liters of water. Okay, so we're going to set that up, and it looks something like this. Okay, you get 224 liters of water from this setup. And we're going to do it again, right? But this time we're going to do it with 13 moles of oxygen. So your setup looks like this with an answer of 582 liters of water. So which answer tells us the final answer, how much water is actually produced? If you remember correctly, it's the smaller answer that tells us our final answer. So really 224 liters of water is produced, and so that tells us that what is the limiting reactant? That hydrogen is our limiting reactant, right? And what do we call oxygen? Just to go over the vocab words, oxygen is our excess reactant. All right, and that's it for gases.